strong acid and strong base titration curve. In the previous video, I've shown on how to plot the titration curve, how to calculate the pH value at each point in plotting the titration curve. In this video, I'm going to show you the strong acid, strong base titration curve pattern. For example, here, the titration curve of pH versus volume of sodium hydroxide. Our strong base is sodium hydroxide. Initial pH, strong acid, so that's why we start with pH equal to 1 because it's strong acid. Initial pH, no sodium hydroxide added yet. So at 0 and AOH, the pH is equal to 1. And then the pattern of the curve is the pH keep increasing because we keep increase the volume of NaOH. So the pH keep increasing until the equivalence point or end point. The equivalence point is pH equal to 7. Before the equivalence point, H3O plus is in excess. The NaOH is the limiting reactant. So that's why the pH is below 7. And after that, after equivalence point, the OH minus concentration is in excess. So the pH value is above 7. Here, initial pH, the pH of the solution before the addition of any base is determined by the initial concentration of strong acid. Before adding any base, V of sodium hydroxide, volume of sodium hydroxide equal to 0, pH is equal to 1. So pH starts out low, reflecting the high concentration of H3O+. None of the concentration of H3O+ used to neutralize the sodium hydroxide yet, because initial pH, no sodium hydroxide. Initial pH and equivalence point, so slightly after initial pH until the equivalence point. As sodium hydroxide is added, the pH increases gradually as acid is being neutralized by the added base. So you add the concentration of OH minus. That concentration of OH minus will neutralize the concentration of H3O plus. So the pH before equivalence point is determined by the concentration of H3O plus that is not yet neutralized. Means not all H3O plus reacted with OH minus from NaOH. Not all of them neutralized with OH minus because before the equivalence point, the OH minus is the limiting reactant. So not all of H3O plus reacts with OH minus. Between initial pH and equivalence point, so starting from here, the pH rises shortly when the mole of OH minus added nearly equal to the mole of H3O plus. So you start to get the straight, it's like a straight line here, slightly before the equivalence point or end point. It means it is nearly equal to the equivalence point. Here means the concentration of H3O plus and the concentration of OH minus is almost equal, but still the concentration of H3O plus is slightly above concentration of OH minus. They are just almost equal at this point. And at the equivalence point, pH at the equivalence point, here the number of moles of base added is stoichiometrically to the number of moles acid have reacted. So here the concentration of H3O plus and the concentration of OH minus, all number of mole have reacted, all number of mole of OH minus, all number of mole of H3O plus reacted. So the solution only consists of salt and water because the salt, when this salt dissociate, becomes cation and anion. The cation and anion comes from strong acid and strong base. So none of the cation or the anion will hydrolyze. So there will no H3O plus or there will no OH minus means no excess reactant. Here, no excess reactant, no production of H3O plus and no production of OH minus from the salt. So only salt and water, and the salt is neutral salt. So the pH is equal to 7 at the equivalence point for strong acid, strong base titration curve. After the equivalence point, all of H3O plus have been used to react with OH minus. All of H3O plus have been used, so OH minus is in excess after the equivalence point because you keep adding the NaOH. The pH of the solution is determined by the concentration of excess base. So when you keep adding more and more NaOH, the concentration of OH minus keep increasing. That will increase the pH slowly again as more base is added. And that's it for titration curve. Now we'll look at the suitable indicator for strong acid, strong base titration curve. Suitable indicators are phenolphthalein and methyl red. The pH for phenolphthalein is 8.3 till 10 and methyl red is 4.2 till 6.3. Either methyl red or phenolphthalein is a suitable indicator because each changes color on the sharp increase of the curve, means this pH range is close to 7. There will be color changes between this pH range. So 4.2 till 6.3 is nearly 7. So there will be the color change. Here, phenolphthalein will be the color change at the equivalence point 7. Suitable indicators for strong acid, strong base titration. Methyl red color red in acid and yellow in base. Chlorophenol blue will be yellow in acid, red in base. Bromo-thymol blue, yellow in acid, blue in base. Cresol red, acid, yellow, base red. Phenolphthalein, colorless in acid and reddish pink in base. These are the range for the pH range for each of the indicators. So the indicators above are suitable because pH range of indicators, the color change, fall within the pH at the equivalence point. So equivalence point for strong acid, strong base 7. So select the indicators that falls the pH range fall at almost 7 or slightly above 7 or in between 7, like these 5 indicators.